Hello everybody, I am Deeksha. Today I'll be talking about decoders and its applications. So, in this presentation, we will be seeing about decoders, the importance of decoders, the types of decoders, the applications of decoders, and one real-time application of decoder which I will be explaining in detail. So, let's begin. What is a decoder? The decoder is an electronic device that is used to convert a digital signal to an analog signal. So basically, a decoder is an electronic device. It has n inputs and we get 2 power n outputs. In digital electronics, a binary decoder is a combinational logic circuit that converts binary information from the encoded inputs to a maximum of 2 power n unique outputs. For example, if the input line, if we have two input lines, then the output will be 4. That is n is equal to 2, so 2 power n will be 4 and that is the output. So a decoder, we can call it as a multi-input, multi-output combinational logic circuit. It converts the n-bit data input into the coded 2n outputs. So basically, it decodes the information hidden by the encoder. Now, coming to why do we need a decoder? The main function of a decoder is to change a code into a set of signals because it is opposite to an encoder, but the designing of decoders is simple. Here, by encoding, I mean generating a digital binary code for every input. The decoder decrypts or obtains the actual data from the received code, that is, it converts the binary input at its input to a form which is reflected at its output. Now let us see what is the difference between a decoder and a demultiplexer. The main difference between a decoder and a demultiplexer is that in a demultiplexer we have a single input and we get multiple outputs, whereas in decoders we have multiple inputs and we get multiple outputs. The main difference between a decoder and a demultiplexer is a combinational circuit that is used to allow only one input as well as direct it into one of the outputs, whereas a decoder allows several inputs and generates the decoded output. Now, let us see the block diagram of a decoder. So here, these are the input lines. These are the N data input lines. This is the enable inputs and this is the 2 power n possible outputs. So if n is equal to 2, then we get 2 power n as 4. So here n is equal to 2 and 2 power n is equal to 4. This figure shows the block diagram. The reason why it is called a block diagram is because we can't see the components that is inside it. Hence, it is known as a block diagram. So this is the basic block diagram of a decoder. So now we'll see the types of decoders. 2 to 4 line decoder, 3 to 8 line decoder and 4 to 16 line decoder. The higher order decoders can be implemented using 2 to 4 line decoder. Here the implementation of 3 to 8 line decoder can be done using 2 to 4 line decoders. A decoder circuit of higher combination is obtained by adding 2 or more lower combination circuits. Here, the 4 to 16 line decoder can be obtained from 2 3 to 8 decoder circuits or 2 to 4 line decoders. That is, um, for 4 to 16 line decoders, we can use 2, 3 to 8, we can use 2 3 to 8 decoder circuits, or or 3 2 to 4 2 to 4 decoder circuits. So now I'll explain 2 to 4 line decoder in detail. That is, I'll include the logic diagram, the block diagram, and the truth table. Similarly, for the other decoders, it will follow along the same way. So now we have the block diagram of 2 to 4 decoder. Here there are two inputs, A0 and A1, and we have four outputs, that is Y0, Y1, Y2 and Y3. Here E is the enable input. It can either be active low or active high. So one of these four outputs will be 1 for each combination of inputs when enable E is 1. Similarly, for when enable E is 0. So here this is A1, A0, these are the inputs as I told, and these are the outputs, that's Y0, Y1, Y2 and Y3. This is the block diagram of 2 to 4 decoder. Now let us see the circuit diagram for 2 to 4 decoder. Here let me A0 and A1 are the inputs, Y0, Y1, Y2 and Y3 are the outputs. For each output is having one product term. So there are four product terms in total. We can implement these four product terms by using four AND gates having three inputs each. And here there are two inverters. This is the first inverter and this is the second inverter. We have the enable input E, which is connected to all the four AND gates. So each of the four AND gates consists of three inputs, one from the enable input, the other two either A1, A0 or A bar, A1 bar or A0 bar. That is the complement of A0 or A1. Now we will see the truth table for 2:4 decoder. From the truth table, we can write the Boolean function for each output. So let me write for Y3. Y3 is equal to E A1 E A1 and A0 Y2 will be E into so for Y1 it is E A1 dash and A0. For Y0 is E, oops, okay, E into, yeah, so these are the Boolean functions. So since there are 4 product terms in total, we can implement these 4 product terms by using 4 NAND gates, as we saw in the previous slide. Here A1, A0 are inputs, Y3, Y2, Y1 and Y0 are the outputs. So here we have the block diagram for 3 to 8 decoder, like we saw in the previous slides for 2 to 4 decoder. Similarly, here is the block diagram for 3 to 8 decoders. Here it has 3 inputs, that is S0, S1, S2, and here D0, D1, D2, D3, D4, D5, D6 and D7 are the outputs, and E is the enable input. The 3 is to 8 decoder can be implemented by 2 is to 4 decoder. So here I've just put the block diagram for 3 to 8 decoder. Similarly, the 4 is to 16 and higher order decoders can be implemented using 2 is to 4 decoder or 3 is to 8 decoders. Now let us see the applications of decoders. Here are some applications of decoders that I found are used in day-to-day lives. First one, it is used in code conversion, that is analog to digital conversion in the analog decoder. It may also be used in data distribution. And I feel decoders are also used in audio systems to convert analog audio into digital data. Decoders are also used it is useful in decoding to binary input to activate the LED segment so that the decimal number can be displayed. The microprocessor memory system selecting different banks of memory. The decoder is used whenever an output or a group of output is to be activated only on the occurrence of a specific combination of input signals. Here are some more applications of decoders. Decoders are also used in a high-performance memory system. The decoder can be used to minimize the effect of system decoding. The decoder is used as address decoders in CPU memory location identification. It is also can be used in electronic circuits to convert instruction into CPU control signals. Here for the second application, address decoders are used, and for this we use something known as instruction decoder. So this is address decoders. Address decoders, and this is the instruction decoder. So in the upcoming slides, I'll be talking about address decoders in detail and how address decoders are used inside the CPU. Now let us see some real-time applications of decoders. For this, we'll take the example of address decoders. So now let us see what is an address decoder. An address decoder is a binary decoder that has two or more inputs for address bits and one or more outputs for the device selection signals. When the address for a particular device appears on the address inputs, the decoder asserts the selection output for that device. So yeah, address decoders are used in CPU. An address decoder is a combinational logic circuit whose purpose is to examine the address and raise and select signal when an address within the block of addresses held in its block of memory is requested. I'll explain this in the upcoming slides. So here we have the figure of address decoder. While reading data from the memory, it is important to decode the address. Hence, a decoder is associated with the memory. So this memory isn't found in the CPU, as we all know. So I'll explain the components of this the memory. Here we have 3 to 8 decoder. So here we have a 3 to 8 decoder. Uh, A15, A14, A13 and A12. These are the address buses. E1, E2, E3 are the enable bits. E1 bar is connected to A15, that is A15 address bus. E2 bar is connected to the ground and E3 is given to a voltage of 5 volts. The output, that is O0, is the output from where the output will be carried. When all the enable lines are 0. So here I'm talking about the working of this. Here when all the enable lines are 0, it enables the memory chip, that is CE bar, which is present in the 2732 EEPROM 4096 into 8 memory registers. So this device again consists of an internal decoder having 12 address buses, that is A0, A1, A2, A3 up to A11. The value of these buses are 1. So the value of these buses are 1. Here, since it was active low, it was 0, but here it is 1. The address bus that is decoded by the 3 to 8 decoder lines is in the range of it has a hexadecimal value, so 0000 to 0FFFH. So here we have a NAND gate. The NAND gate is connected to the input-output buffer. It has two inputs, that is input-output buffer, input-output memory, that is IO/M bar, and RD bar, that is read memory. The memory read MEMR bar is performed when both IO/M bar, that is input output memory, and the read memory are low. The output is enabled and hence the output buffer starts working, and the data that is fetched from the address bus is passed to the output buffer and then the data is read. See here is the working of the address decoder, which I explained in the previous slides. While reading data from the memory, it is important to decode the address. Hence, a decoder is associated with the memory. Here, we use a 3 to 8 decoder, which has 4 address buses, A15, A14, A13, and A12. The decoder gets enabled when their value is 0. Even is the enable bit that is connected to A15, it is active low. E2 is connected to the ground, it is again active low. E3 is connected to the 5-volt supply. Address decoder. O0 is the output from where the output will be carried. When all the enable lines are 0, it enables the memory chip CE bar, which is present in the 2732 EEPROM having 4096 into 8 memory registers. This device consists of an internal decoder having 12 address buses, that is from A0 to A11. The value of these address buses are 1. It shows and fetches the data. The address bus that is decoded by the 3 to 8 decoder lies in the range from 000 Hz to 0FFFH. We saw that below there was a NAND gate that was connected to the input-output buffer. It has two inputs, that is input-output memory and the read memory. The memory read MEM bar is performed when both IO/M bar and RD bar are low. The output is enabled and hence the output buffer state output buffer starts working and the data that is fetched from the address bus is passed through the output buffer and then the data is read. So this is the working of the address decoder. Now we come to the end of this presentation. Thank you.